the difference between normal Linux and UserMode Linux. So normal Linux is, as we know, we already have an hardware, and these hardwares will be controlled by the Linux kernel, and on top of the Linux kernel we'll have process 1, process 2 running, etc. But this UserMode Linux is a method which is used on top of the normal kernel itself to compile it as a process. So you can compile and run it as a process. For example, you have a process 1, right? So here, instead of process 2, this Linux kernel will be modified as a UserMode Linux. That is, you can run it as a process itself. And on top, so that's how this is called as a UserMode Linux. So that is why it is called as a UserMode Linux, where you can run kernel in the user mode. User space, kernel space. If you understand, then you will know that we are trying to compile the kernel and execute it in the user mode so that it doesn't crash. So it will be like a one. If any problem happens in the kernel, it will only crash that particular process. For example, here process 2. So this is one example. So we'll see what are the different reasons for using. For example, so why would I want a user mode Linux? See, if a user, as I said, if a Linux crashes, a host is still fine, because only the process 2 is crashed. So you can run it in a user mode kernel as a non-root user also. So you can debug like any normal process. So in normal kernel, if you want to do anything, any debug, any problem you face, then you have to use the trace, all those things. But here you can use it as a normal process itself. Then you can run the GPF profiling, coverity testing, all these things in the kernel itself. You can play with the kernel without breaking any things, like drivers, all those dependencies are completely removed. Then you can use it as a sandbox for testing other applications also, and you can try to do new development or kernel safely without rebooting, because it is as a process. Whatever crashes, only the process crashes. And in the same Linux machine, you can have different distributions. For example, here Ubuntu, then Ubuntu kernel alone, you can some other architecture, that also you can, anything you can, sorry, not architecture, different distributions of the kernel. You can, for example, 5.4, the 6.2. So like the different distributions also you can compile and test. So this is the advantage. So now we'll try to take a kernel and compile and check. So I'm going to download 5.4.14. So this is where it was tested. So I'm just showing that. Use this command to download it, and then we have to extract it and compile. To unzip it like this. So unzip this kernel. This is the actual normal kernel only. Instead of compiling the kernel code, we are compiling this as a user mode Linux. So tar it, untar it. Next we have we have got a Linux now. See, this is normal Linux. So what you have to do is make menu con. This is what we need to do. So we need to enable some parameters for us to work. What are the basic things I'll say? So general setup. You have to go to specific options. If you want, you can force static link library, all those things are not required for us. Main thing is go to character device drivers. Here you need to enable all these devices. Null, port, PTY, extern, everything. Graphical devices, UML drivers. UML drivers are not required. Networking support. Networking options, you can 802.2a, whatever required you can enable. Come to exit, and then device drivers. Sorry, not required. Go to file system. File system we need. because we are running ext3 ext4, so you need ext4 and ext3. Enable this. And for network devices, UML network devices you need to add. Over here, virtual device, Ethernet and tab, SIP, all those things. VD not required, multicast. PCAP will not work, but actually main thing is Ethernet tap and twin tap alone is sufficient. If you want, you can add the other things. It is saved in .conf. Here you can see twin tap. See all the tap interfaces. With that, whatever required, you can see here, and as per the requirement, you can add fields you want. Then you give make Linux arc equal to UML is that architecture is a UserMode Linux. That's the meaning. Just give make. It will take some time. Once it is compiled, you can check. There you can just add this path. UBDA. So how to compile, how to run this is, go to this path where you have created the root file system, then give the path of the Linux and then UBDA root file system to start it. So now what error we are facing? Previously we thought it is a root file system is missing. Now we are saying cannot open the VFS file system. That means in Linux kernel some virtual driver may be missing. So now we will see whether we have enabled that. Now go back to the Linux where we have compiled. Just do make menu config. Make menu config arc equal to UserMode Linux. Now here go to the drivers. This is a block driver. Go to block driver and say that this is virtual block we have not enabled. Try to enable it and see whether UBDA is there. So you always sync this. We need to enable. Come exit. So now we have made changes. Save it. Make Linux arc equal to. We'll compile and check whether now this is working or not. So now only these drivers are UBD kernel drivers and co-user drivers are enabled. Now it should work. We'll see. We'll come run. So now we'll use the script to start the Linux. So now root file system is ready. Now we know how to compile the Linux kernel and we have compiled it. So previously when we try to reboot without the file system, what happens? It crashes like this saying I don't have a file system. See. So now give the file system whatever we have created and boot. So you are able to, we have booted it. You can see welcome to BusyBooks. So socket is not connected because we need to give the turn tap interface. Now I'm just killing it. For that you need to create a tap interface. So for this example we'll see how, now we know how to create a Linux and how to boot a file system. Next step is we'll try to connect an interface and check. So consider this diagram. Now consider this setup. So now we are going to make this setup. Basic networking using UserMode Linux. So here to start with this video you should know how to compile a BusyBox, and then you should know how to create a root file system, then you should know how to create a Linux. So all these are done in the previous videos. You can check them. Once you are familiar with it, then you can come to this step. So here what we are going to do is we are going to create two tap interfaces, tap 0 and tap 1, and then connect the UML Linux using this tap interface. That's it. So this will become like a network from R1 to R2. Different networks you should be able to ping, where this Linux block acts as a router. So you have to enable forwarding in this Linux router. We'll see how to do it. Now you need to create a tap interface. So this is the command to create a tab interface. IP turn tab add mode tab 0. So if you don't have a tab interface, I'm trying to create it. I have a tab interface tab 0 and I'm creating tab 1. So two interfaces are created. I'll just assign an IP address tab 0 and tab 1. So we'll see self ping is working. This is working. The other one is, so both are working. This is the first step. First step is to create a tab interface. Before this, you should have already compiled a Linux with the UserMode Linux, and you should have created a file system. This rootfs. The previous videos I have explained how to create this and how to compile this Linux. If you have any issues, you can see them. Now we are going to give this ETH0 as a turn tab interface to this. So now we'll see how it works. I'm just giving this command here in R1. Sample. In this folder, I'm going to start. This is R2. R2, same folder you can go. And here we are going to start the second interface. Okay, this is working. Okay. So here what we have to do, we have to copy this file system. So now two different instances we have got. So this has a net device of this iMac. This has a different net device. So previously I just tried to run the same thing, so it was not working. So now we got this if config. Because you need to compile the Linux code with the address family. Since we didn't compile like that, we are getting this error. Now we need to compile the Linux family, address family. We'll see how to do this. Now kill this like this, kill -9. So this will kill all the processes. Now we need to recompile the Linux kernel. So to get the network options, what we have to do is go to make menu config arc equal to um. So you have to go to UML network devices, and here you have to enable it. It is already enabled. Then you have got networking support. Here networking options. 820 bridge, TCP socket, this one packet socket, Unix socket, TCP. Not 1D, it is already there. So all these you should enable, and then you need to recompile it. Fix it. Yes. So make Linux arc equal to to recompile the kernel, then we need to boot and check. Just give the same command. We need to wait until it compiles. So the kernel is recompiled now. Now we will see, boot and check whether we are able to get the address correctly. this first one, and now we are not getting that error hyphen a. So this is the other side. Config. So now you need to enable it. If config is 0 up. You got this. The other one is if config is 0. So now we need to assign IP addresses. R1, how did we create? We created with now we need to see the file which we have used. So R1, this is R1, we have created with tab 0. So if config tab 0 you have this network 100.100. So now you should try to assign an IP within that range. 2 255.0. Try to ping to the other one 100.100.1. Okay, it's working. To self ping is not working. Okay. E0. Now we are trying to ping to the tab interface in the Linux machine. That is, as per this diagram, from this UML1 you are trying to ping to this interface. So that is E1. We'll try to capture here and see. TCP/DEM. So echo request and echo reply we are getting. So we need to enable this also. etc proc sys IPv4 IP_forward. So this we should enable for Linux to act as a forward. So now tab 1 we are getting, but sorry, tab 0 tab 1 we are not getting anything. Now we will try to make this happen. This is the interface. Config 80. Now we will see what IP we have assigned. Tab 1 is in this network. Config. So within this network we need to assign an IP. If config 0 to netmask 255.255.255.0. Now ping should work. See, it's working. We can capture this in tab 1. So you can just send from R1 alone and check in tab 1. You should not receive. It should be received only in tab 0. Now you can stop in R1 and you can just try to send in R2 and try to capture and check if tab 0 and tab only in tab 1 it has to receive. Now we will try to do end to end. So now we try to ping to the outside network, that is tab 1 interface. If config tab 0 tab, we will try to ping to this interface from R1. It won't go because there is no route. Now you should try to add a route. So this is the route. We'll try to add a route for that. So IP route add to this network, we need to go via 100.1. Same way we should add in R1 also. IP route add for 100.100.0/24 via 100.100.200.1. Now you can see route -n. Now ping should work. See, ping is going from R1 to R2. So here also you can ping to not from R1 to R2, R1 to tap interface. That is, we are able to ping from R1 to this tap 1, and from R2 to tap 0 we are able to ping. Now we should be able to ping from R1 to R2 also. We'll try that, and before that you can capture the packet and see. Tap 0, you can see reply request, tap 1 also required 2. This should be given reply by R2. And 100.1. Sorry, this is wrong. 100. So both ends it is working. So this is a very simple and easy network. Just to check connectivity, we can try to add different applications to check also, sockets and something like that we can also try. So if you have any change in the kernel, then you can just directly change it, and you can compile like this, create a file system and test it. So for that, I'll just recap. To execute this, you need to run these two commands. That's all. You need to create 2 tap interfaces and compile a kernel with UserMode Linux and create a file system and connect them and add static route so that we can reach from R1 to R2. So it is very simple steps. You can try. Thank you.